Now let's continue with this indeterminate form, which is infinity over infinity. So let's say limit as x approaches a, f of x is equal to plus minus infinity, and limit as x approaches a, g of x is equal to plus negative infinity. So in this case, the function f of x over g of x has the indeterminate form infinity over infinity, right, at this point. So to find the limit, we must divide the numerator and denominator by x of highest degree. So let's look at this example. Here we have limit as x approaches to infinity, 3x squared plus 4x over x squared plus 2, right? So which one has the highest degree? Here x squared has the highest degree, right, which is 2 here. So we will write this as limit as x approaches to infinity. So we will take the parentheses of x squared here, and then it's 3 plus, so this will be 4x, right? So when I take this parenthesis, so this will be 4 over x. Why? When you multiply these two, you will get 4x, right? 4 over x times x squared, that is equal to 4x. So over, here we have x squared, so it's 1 plus, we have 2 here, so 2 over x squared. Why? Because when you multiply these two, you will get 2. So let's continue. Now here we can cancel out these two. It was actually our aim to simplify this. Now we can put infinity instead of x. Okay, so when I put infinity instead of x here, this will be number over infinity, and number over infinity, that is equal to 0, right? Also here we have number over infinity, which is equal to 0. So from here it's 3 plus 0, which is equal to 3 over 1 plus 0, this is equal to 1. So 3 over 1, this is equal to 3. Now you will learn one trick which is very, very important. If the highest degrees of denominator and numerator, if they are equal to each other, then the ratio of coefficients will give you the answer. What do I mean by that? For example, here we have limit as x approaches to infinity for x cubed plus 2x squared plus x over 3x cubed plus x squared plus 2, right? So as you can see, we have here x cubed and in the numerator and also in the denominator, and they are the same, right? They are equal to each other, highest degrees. So I can say that this limit actually is equal to 4 over 3. You just take the ratio of their coefficients, 4 over 3. Okay, so let's also use the other way we did before. So limit as x approaches to infinity. So here we said that x cubed is it has the highest degree, right? So x cubed, we will take the parentheses of x cubed, and in the parentheses it's 4 and then plus 2x squared, and I have here x cubed, so I can write this as 2 over x, right? Because when you multiply these two, you will get 2x squared, plus we have here x, so this will become 1 over x squared, right? Yes, when you multiply these two, you will get x. Okay, and in our denominator we have x cubed, parenthesis, it is 3, okay, plus x squared. I can write this as 1 over x, okay, because x cubed times 1 over x, it's equal to x squared, plus we have here 2, so I can write this as 2 over x cubed. Okay, now as you can see, x cubed, so I can cancel out these two, and now we can put infinity instead of x. So when you put infinity instead of x here, 2 over infinity, this is equal to 0, 1 over infinity, this is equal to 0, 1 over infinity, this is equal to 0, and 2 over infinity, this is equal to 0. As you can see, these are all equal to 0. So we already cancel out these two, and now as you can see, our limit is equal to 4 over 3. So as you can see, we got the same answer. So when you see this kind of polynomials, okay, and in the numerator and denominator, if they are highest degrees, if they are equal to each other, you just take the ratio of their coefficients. Now in this example, we have limit as x approaches to infinity, 2x plus 3 to the power of 10 times 3x minus 2 to the power of 20 over x plus 5 to the power of 30. So when we put infinity instead of x, we will get infinity over infinity, right? So what we can do here, we can actually divide both the numerator and denominator by x to the power of 30, which is the highest power of the fraction, right? So let's do that and let's see what happens. So limit as x approaches to infinity. So it's 2x plus 3 to the power of 10 times 3x minus 2 to the power of 20 over x to the power of 30. Okay, again over, it's x plus 5 to the power of 30 over x to the power of 30. So now here x to the power of 30, I can actually write this as x to the power of 30, it's equal to x to the power of 10 times x to the power of 20, right? So we can write this separately as, here we have 2x plus 3 to the power of 10, and here we have 3x minus 2 to the power of 20. That's why I want to write this separately, okay, because they have the same exponent. So let's do that. Here we have 2x plus 3 over x to the power of 10. Okay, this is the same thing. Times 3x minus 2 over x to the power of 20. You see, this is x to the power of 10, x to the power of 20, so it's equal to x to the power of 30. Divided by, it's x plus 5 over x to the power of 30. I can also write this one like this. So now we can here we can also write this separately. So let's do that. Here of course we have limit as x approaches to infinity. So here we have limit as x approaches to infinity. So here 2x over x plus 3 over x to the power of 10 times 3x over x minus 2 over x to the power of 20 over, this is x over x plus 5 over x to the power of 30, right? Okay, now here we get 2, so now we put infinity instead of x, so 3 over infinity, this is equal to 0, right? So here we have 3, so 2 over infinity, this is also equal to 0, and here we have 1 and 5 over infinity, this is also equal to 0. So what we have here now, we have here 2 plus 0, it's equal to 2, so 2 to the power of 10 we have here, times we have 3 here, 3 minus 0, it's equal to 3, so we have 3 to the power of 20 over, so we have here 1 plus 0, it's equal to 1 to the power of 30, which is equal to 1. So here we have 2 to the power of 10, so I can write this as 3 to the power of 10 times 3 to the power of 10, right? It's the same thing, 3 to the power of 20, and this would be 2 times 3, it's 6, 6 times 3, it is 18, so 18 to the power of 10 is the answer for our example. In this example, we have limit as x approaches to infinity to x to the power of 4 plus x minus 1 over 5x cubed minus 2. So there is one trick here. As you can see, degree of the numerator is greater than the degree of denominator, right? So it shows us that the numerator is getting bigger faster than the denominator because x goes to infinity, right? So here x to the power of 4 we have in the numerator, and in the denominator we have x to the power of 3. So this shows us our numerator is going up, it's getting bigger faster than the denominator, so which make this limit equal to infinity. Okay, so let's prove it. So limit as x approaches to infinity, so we take the highest degree, right? It's x to the power of 4, so x to the parenthesis of x to the power of 4, so this is 2 plus this is 1 over x to the power of 3, right? Because when I multiply these two, I will get x minus 1 over x to the power of 4. And in the denominator, we have x to the power of 3. So I will take the parenthesis of x to the power of 3. So it will be 5 minus 2. We have here 2 over x to the power of 3, right? Now, here, when we simplify these two, we will get x. So here we have 1 over infinity, it is 0, 1 over infinity, we have 0, 2 over infinity, we have 0, but here we have x, which is equal to infinity, right? So this is infinity times 2 over 5. So still, this is equal to infinity. As you can see, our answer is infinity. So let's say you have a limit like this, limit as x approaches to infinity. Okay, now let's say the degree of numerator is less than degree of the denominator. Now what happens? So 5x squared, let's say it's minus 3 over x cubed plus 2x plus 3. Okay, let's say. So here, same logic. When we have a limit like this, the degree of numerator, as you can see, it is 2. It's less than the degree of denominator, right? It shows us the denominator is getting bigger faster than the denominator, which makes this limit is equal to 0. When you try, when you try to solve this with the other way, actually you will take the parenthesis of x squared, right, in the numerator, and you will write your values here over, you will get here x to the power of 3, and you will write your values here, and as you can see here, these will cancel out each other and you will get your x in your denominator. So here will become equal to some number, okay, and here you will get infinity. So number over infinity, it will be equal to 0. As you can see, same answer. So this is a very useful trick, especially when you enter your exams and it's a test. It's very important for you to know this formula. Now let's continue with these examples. In the first example, we have limit as x approaches to infinity, square root of 9x squared plus x minus 1 over 2x plus 3. So when we put infinity instead of x, we will get infinity over infinity. Okay, so what we should do, we should take the highest degrees. So when it comes to this one, let me rewrite here. So limit as x approaches to infinity. So here square root of 9x squared. So I can take this 9x squared as it is. Why? Because after that it will be easier for me to take out this 9x squared as 3x. Okay, so 9, because it's in the root, so it's 9x squared in the parentheses. In the parentheses we have 1, it's plus, it's 1 over 9x, right? Yes, when you multiply these two, you will get x, and then it's minus 1 over 9x squared. Okay, over here we have x as our highest exponents, x to the power of 1 is the highest exponent here. So x in the parentheses of it's 2 times 3 over x, right? When you multiply these two, you will get 3. So let's continue. So here 9x squared, I can write this as 3x. Okay, so this will be 3x, and here we have 1, and here we have 3x over, let me write this, so this 3x times, we have here 1 plus, these are all in the square, this is 1 plus 1 over 9x minus 1 over 9x squared. Okay, x times 2 plus 3 over x. Okay, now of course limit as x approaches to infinity. Now these x, they cancel out each other. We have 3 here, so here we have 1 over infinity, this is equal to 0, 1 over infinity, this is equal to 0, 3 over infinity, this is also equal to 0. So here we have 3, we have here square root of 1, which is equal to 1, so it is 3 over, we have here 2 plus 0, which is equal to 2. So our answer is 3 over 2. So let's look at this example. Here we have limit as n approaches to infinity, n to the power of n plus 5 to the power of n plus n to the power of 5 over n factorial plus 5 to the power of n plus 5 to the power of 55. So here we have these all values, and let's now in this fraction, which one is the greater, n to the power of n or n factorial? Now let's give some values to n. Let's say it's 3. Okay, so 3 to the power of 3, it's equal to 27, right? So 3 factorial, this is equal to 3 times 2 times 1, this is equal to 6. Now as you can see, n to the power of n is greater than n factorial, which means here in the numerator, as we said before, the numerator is getting bigger than it's getting bigger faster than the denominator. So that's why its limit is equal to infinity. Okay, so that's why its limit is equal to infinity, and this infinity is our answer to our example. Now let's see how we solve problems when we have this kind of indeterminate forms. So indeterminate forms of these types can usually be treated by putting them into one of the forms 0 over 0 or infinity over infinity. Or if you have functions, you can factor them if you can. So for example, if you have 0 times infinity form like here, okay, so you can write this as 0 over 1 over infinity, right? It's still the same, 0 times infinity. So this 1 over infinity, this is equal to 0, right? So from here you will get 0 over 0. Or same thing, 0 times infinity, you can write this as infinity over 1 over 0. Why? Because 1 over 0, its limit is equal to infinity. So from here you will get the indeterminate form infinity over infinity. So let's look at this example. Here we have limit as x approaches to infinity, x times sine 3 over x. So here, as you can see, we have this. This is infinity. When I put infinity instead of x, so this is infinity times 3 over infinity, that's equal to infinity. So sorry, this 3 over infinity, this is equal to 0, so sine 0 is equal to 0. As you can see, from here we get infinity times 0 indeterminate form. So what can I do to find the value of this limit? So I can write this as limit as x approaches to infinity, okay, sine 3 over x, okay, over, I can write this x as 1 over x in our denominator here, right? So from here, as you can see, when I put infinity instead of x, still still I get 0 over 0, right? Because when I put here infinity, 3 over infinity, this is equal to 0. Assign 0 is equal to 0. So this is equal to 0 over 1 over x. So when I put infinity here, so 1 over infinity, this is also equal to infinity. But I know one formula here, which is, so I have here 0 over 0, right? And I have here sine function. So this sine function, I can write this as limit as x approaches to infinity, sine 3 times 1 over x over 1 over x. Why? Because you see we have here 1 over x, we have here 1 over x, and it is 0 over 0, 0 over 0 indeterminate form. So these expressions, they are equal to each other. So I can take the coefficient of these coefficients of these expressions. I mean, I can take their ratio as a result of our limit, right? This was our rule. So here we have 3 and here we have 1 as our coefficient. So this is equal to 3 over 1 and this is all equal to 3. Now let's continue with this example. Here we have limit as x approaches to infinity, x over x plus 1 minus x over x minus 1. So here what we can do, let's divide both numerators and denominators by x and let's see what happens. So here limit as x approaches to infinity. So this numerator, I will write this as x over x, okay, over x plus 1 over x minus, this one is also same, x over x over x minus 1 over x. Okay, so from here, as you can see, this part is equal to 1, this also is equal to 1, and here we can write this separately. Let's do that. So here we have limit as x approaches to infinity. So here we have 1 over, this is x, so I can write this, let me write it here, x over x plus 1 over x, right? This is the same thing. And also for this, I can write this as x over x minus 1 over x. So this is also equal to 1, this is also equal to 1. So here we have 1 plus 1 over x minus, here we have 1 over, here we have 1 minus 1 over x. So now I can put infinity instead of x. So here 1 over infinity, this is equal to 0. Here also 1 over infinity, this is equal to 0. So our answer would be 1 over 1, it's equal to 1, minus 1 over 1, this is also equal to 1. So 1 minus 1 is equal to 0, and this is the answer for our example. Limits of series. So let's say we have a limit like this. an is equal to 2 to the power of n minus 5 to the power of n plus 1 over 2 plus 5 to the power of n. So how we find the limit of this series? So they don't have to tell us where to this n approaches, okay? Because we know that series increases till infinity. So these n's are approaching to infinity. So here actually what the question is asking us is actually limit as n approaches to infinity, okay, 2 to the power of n minus 5 to the power of n plus 1 over 2 plus 5 to the power of n. Okay, so here we can write this as limit as n approaches to infinity. So here we can take 5 to the power of n as a common factor. So 5 to the power of n. So here we have 2 to the power of n over 5 to the power of n. And then minus, we have here 5 to the power of n plus 1. So we can write this as 5. When I multiply these two, I will get 5 to the power of n plus 1 over this part I will take 5 to the power of n parentheses, and this is equal to 2 over 5 to the power of n plus 1, right? So okay, now I can cancel out these two, and here as you can see we have actually, this is actually equal to 2 over 5 to the power of n. So I have here simple fraction, right? So when it comes to simple fraction, what was its limit? Its limit is equal to 0 because n approaches to infinity. That's why its limit is equal to 0. So here we have 2 over 5 to the power of n. So this is equal to infinity, and 2 number over infinity, this is also equal to 0. So from here we have minus 5 in the numerator, we have minus 5, and in the denominator we have 1. So minus 5 over 1, which is equal to minus 5.